Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam Iskandar bin Azmi. My number matric is S72457. So today I will present my assignment for the MTK 3032 Statistic for Chemistry. As you can see, this is my lecture data, Dr. Hanafi. So, how I get 32 random data from this? So first thing first, I just replace his name with my name, Adam Iskandar. Okay, and I will get my data like this. This is my data, my original data from my lecture data, and from this data I can answer all the 6 questions that I will explain next. Alright, for the first question, find the 90% and confidence interval for the average serum cholesterol data. The population standard deviation is 22. So the standard deviation is given in the question, that is 22. So how can we do this question? So first thing first, I'll show you my calculation. We have to find the mean, the average of the data that I will show you later. This is my average. Then the standard deviation is given in the question. Then the Z score for the 90%. I get it from this table. So for the 90% of confidence level, the Z value is 1.645. Alright, so we use this calculation, the confidence interval formula, like this. So I get the average from this data. So I sum up all this data, this color red and blue, and I get this 217 and 4 217 point 217.4688. Then I sum up and I put all the given data in this formula and I get this 211.0713 and 223.8663. Alright, for the second question, find the 90% confidence interval of proportion of education level is graduated degree. So if we scroll down, it says that education level value are defined as follow. Graduated degree as 3. So back to the data. As you can see, I have labeled those data and I get only 2 from all this, that is 3. Alright, so our x is 2. Alright, so this is my calculation. I use the Agresti and Cole method. So in this formula, we say that P prime equal to x plus 2 over n plus 4. X is 2 and n is 32. Alright, so it's given that 90%. So if we want to find the A, we have to subtract by 1 equal to 0.05. And then we just get in this formula with all this value and just put all the information into this formula and we will get this answer. Alright, for the third question, find the 95% confidence interval for standard deviation for width of male respondent. Alright, as you can see here, we want the width of male. So back to the data again. Wait, as you can see, I have labeled all those information for male, like this yellow thing for male, male, and all this for male. And yeah, so go to the calculation. Alright, so this is my calculation for the number 3 question. So after I calculate all those information, I got standard deviation as 22.83 and 15 For significant level A, I minus 1 minus 0.95 and get 0.05, and just added all those information in this formula. How I get this to value? Alright, so for the first data, I get 26.119, and for the second data, I get the 5.629, like this. This is the two data I get from the chi-square table. Alright, then when I get all the data, I just add to this formula and get this answer, 16.71 and 36. Next, we go to the fourth question. Test the hypothesis that the average serum cholesterol is different from 215 mg% at A 0.05. The population standard deviation is 22. So, same like the first question, it asks us about serum cholesterol, and the standard deviation is also given. Right. We go to the calculation. This is my calculation. So I just list all the given information from the question like this, and I use the t-test formula to calculate this question. So for the question, it asks about the hypothesis. So the answer is, so the true value not fall in the critical region. Critical region is in this and this. So I have to accept the null hypothesis, HO. Then there is no enough evidence to support the claim that the average serum cholesterol is different from 250 mg. So the final value I get is 0.6348 from this question. 270.4688 minus 250 over 22 over sec 32. So I get this value and I can answer this question. Okay, for the question 5, it asks, is there any significant difference on average serum cholesterol between male and female respondent at A 0.02? Assume different variance. So this question asks us like the same previous question, number 1 and number 4, but now it asks us about male and female respondent, and the A is 0.02. Alright, let's go to the data. Okay, as you can see, the data I highlight as a blue color and the red color. The blue color assume for the male and the red color for the female, and I just made the average for the man, average for the woman, variance for the man, variance for the woman. So this is the data. Okay, for the calculation, I use also same like the previous question. I use the t-test formula from the given information like this, and I just added the information from the data to this formula, and I get the 0.307. Same like previous question also, we have to explain about that question. We have to explain about this different variance. So find the p value like we do this for z 0.307. The error is 0.6433, and 1 minus 0.6443 equal to 0.3557. Since the p value is larger than the a, that is 0.3557 more than 0.02 from the question, the decision is to not reject the null hypothesis. Do not reject the null hypothesis at A equal to 0.02 since the 0.307 less than 2.33. 2.33 we get from the z-score table. When we find this 0.01 from this, the significant level, we must divide by 2 and then we will get the 0.01 and then we find it on the table and we will get plus minus 2.33. Alright, so there is not enough evidence to support the claim that the mean are not equal. Hence, there is no significant figure. Alright, finally for the last question, build a simple linear regression between X equal to serum cholesterol and Y equal to systolic pressure. So in this case, we can use a linear regression formula like this from the Blumen chapter 10 in the statistic textbook. We have to find the A and we have to find the B. But how? Alright, let me show you. So first thing first, we must go to the data again and we must arrange data for serum is X and cysto is Y, like this. And we have to make a data X times Y, X times X, like X squared. And sum it all and we get 4 different data, 4. Okay. Okay, back to the calculation. Alright, this is my calculation. Let's say X for serum cholesterol and Y for systolic pressure. Right. For the sum X, I get 6,959. For the sum of Y, I get 4,142. For the sum X times Y, I get the 900,000. 3,855. For the X squared, I got 1,500,000 30,770. For the N, I got 32. Okay, so we use the formula for the regression line y prime equal to a plus bx, like this. So I just added all the data to this formula and like this to get the value for A and the value for B. Lastly, I just add the value for A and value for B in this formula like this. So that's for the last question. I hope you guys understand and enjoy my explanation. It might be boring, but yeah, I just tried my best. So that's all from me. Thank you.